Hi everybody. So I was asked on Saturday to give this talk, and I was asked what I was going to talk about, and I said, well, I'm not going to talk about the same thing I talked about on Saturday at the Bacon conference. I want to talk about why data is awesome. So that's the title of my talk. I'm afraid I have no bullet points or enterprise acronyms for you at all, but I do have a kit and a couple of equations, so I hope you'll enjoy it. So for those of you who I don't know, which is many of you because I'm from New York, if you can't tell from the not very sexy accent, I'm the chief scientist at Bitly. At Bitly we take big things and make them tiny. That's the Pufferfish logo. We're a platform for people to share bits of content around social networks, and people do this quite a lot. So we see data that's on the order of about 80 million new links being shared every day, and hundreds of millions of clicks on those links, and we actually fetch all that content to you, so we have a lot of fun text and image and video data and whatnot. And so I have a team of really awesome people, mostly refugees from academia and physics, mathematics, and computer science, and we sort of sit around and think about this data and build products on it, answer questions about it, and sort of reflect on human behavior through this one tiny little window. And I thought this talk would be a good opportunity. This is just so I get the caffeine effect from seeing the cup of coffee, because I'm still a little jet-lagged. But it would be a good opportunity to think about what it means to be a data scientist, and what it is that we actually do, and where this whole thing is going. So I thought I would write down my definition, and then you can tell me why I'm wrong. If you didn't catch it on the first slide, my Twitter handle is hmason, and my email is h@bitly, so I know we're not allowed to do questions here. But if you have questions or comments, tweet them or email them, and I'll respond to them or on the panel a bit later. So I think data scientists do three things. And the first one is they do math. That is, they build a reliable, internally consistent system that reflects some aspect of reality. And this is math in the sense that physicists do math, and that there's some system you are trying to understand, rather than the sense that pure mathematicians do math, where they're just making beautiful things and who cares about the real world. Then we write code. That is, we take that beautiful math off the whiteboard and put it into something where it can actually run on the data. But before you can do any of that stuff, we ask questions. And this is actually, I find, the hardest skill to identify when we're recruiting. Lots of people know math and lots of people write code, but it's very hard to find people who know math and write code and ask really good questions. Good questions. So these people, I generally find, are people who blend a bunch of different backgrounds. This is my favorite slide for explaining it. So yes, there is an infrastructure piece, there's a mathematics piece, there's a computer science piece, and a curiosity, human, social science, empathy piece. Lots of people live at the intersections of these things. Data scientists live here, where they're awesome nerds, which you probably can't see because it's cut off the bottom. And there's a pretty well understood way that people work with these kinds of problems. And this is a framework I developed with Chris Wiggins, who's a professor at Columbia. It is, you obtain your data wherever you get it from. I usually don't ask questions about that. You scrub it, you clean it up. That's usually way more work than you think it ought to be. You explore it. That is, you don't know what's in there. You can plot it along all these axes. You can start to think about it, join it with other data sets. Model it is when you do the hard work. And interpret it is the last piece, and that can mean making an Excel spreadsheet that you give to some business person. It can mean making a visualization. It can mean writing a paragraph. That is, you take what is a very complex mathematical and data system and you render it in some way that any human being can understand it. And that's also where data visualization comes in. And we chose these words because if you take the large letter from each one and pronounce it, it sounds like awesome. So it's really easy to remember. There's a bit.ly link down at the bottom if you actually want to read the article. And I wanted to dwell briefly on the building a model piece. So this is one of my favorite images. It is a candle burning down over 15 hours. And you might intuitively, if you didn't really think about it, and you had to draw a line for what a candle looked like burning down, you might draw a straight line. But when you look at this photo, you absolutely understand what this function looks like completely intuitively. And so this is what we do. We describe these sorts of behaviors from discrete data points. Do you agree with me so far? Yeah. Is everyone asleep? Yeah. All right, so there are a few reasons why this is happening now in 2012. And it didn't happen 10 years ago. And this is the first one, right? You can, on my little MacBook Air that fits in my pocketbook, I can spin up a cloud of machines that can sequence my own DNA. And I, as a individual who's not immensely wealthy, can actually afford to do that. And it can happen fairly quickly. So that's amazing. The second reason is that we actually know what to do with some kinds of data. I'll get into this one again in a bit. And the last reason, of course, is that we actually have data, and that deserves balloons. I realize now I put all my jokes at the bottom of the slides. For the future, I'll have to bring them up. So people are recording all of this data, and we're finally sort of asking, what can we actually do with it? And if you're on the West Coast, that's what can we do with it to change the world. And if you're in New York, that's what can we do with it to make money. And I haven't quite figured out what London is yet. But we're really, really just at the beginning of this. This is just an excuse to put a rocket in my talk, and because I wanted to remind myself to talk about, in the same way that space technology developed and then stagnated, we've hit a point where our technologies are developing, but may, in fact, stagnate as well. We need better tools for a lot of different pieces of that process. And in order to illustrate this point, I thought I would walk you through some of the projects we've done at Bitly and the advanced mathematical tools we've used. The first one is counting. We do this quite a lot. In fact, we have a small Hadoop cluster. It is really good for counting things in a distributed way and not good for much else. One thing we decided to count was how people use different devices, right? So we went and took all the Bitly clicks, took the user agent of those Bitly clicks and made a graph. We have Monday here. This is all normalized by time zone. So Saturday and Sunday are those nice diurnal humps at the right side. And then we put them in a bunch of different categories. So desktop here means any computer browser. We're still struggling with the semantics of that because obviously this is not a desktop. A phone is any smartphone that is an iPhone, Android, etc. A tablet is mostly iPad, but a couple of Android devices. And a gaming device is things like a Nintendo DS or a PS3. And you'll see that Thursday nights has a huge peak for gaming devices in the evening. We blame that on college students. We also went and looked at the similarity by device use and time. So if it's white here, it's identical, and if it's darkly colored, it's very distinct. And you see a few neat things, like the Kindle is completely different from any other device. People use it totally differently. Windows and Linux are much closer together than the Mac OS in either of those two things, which says I think that geeks are not that different from the rest of us, and there's hope for humanity after all. BlackBerry is quite different from iPhone and Android. Does anyone here still use one? All right, that answers the question, sorry. So another thing we did just by counting is, this is a piece we did with Forbes. It was in the April 9th print edition, and it's online. If you Google it, it'll come up. And it's looking at the most disproportionately influential news sources by US state. And so we took a bunch of the top news sources, and we just looked at how far in a given state it diverges from the mean, and then picked the one with the greatest divergence. And there are a few things here that are, well, I know this crowd isn't really into US media, so I won't dwell on it too much, but Fox News in Texas, no surprise, NPR in Oregon, The Onion in Wisconsin. And as a preview as future work, we have a very similar piece that we're collaborating on with The Guardian for the UK, which should be out shortly and probably more entertaining in this current. So the last thing we learned by counting was the cutest kitten viewed through Bitly in all of 2011. That's it. And unfortunately, when you deal with a fair amount of scale, which we do, counting cleverly often wins out over really fancy math or good machine learning algorithms. So I wanted to give you an example of one thing we did by counting cleverly. And this is figuring out which spoken languages are present in a particular web page. So you would think this is an easy problem to solve. Lots of people have done it. You can go to the Google Translate API. You can build your static classifier off of a trained corpus of labeled data. There are a couple of different techniques. You can look at words and word distributions. You can look at letter distributions. But what the heck language is this? So if you ask Google, this is English. If you ask us, it's Japanese. Because it is a Japanese language tweet using English words, but it's the name of a something. It's not. This page is only of interest to Japanese speakers, and we see a lot of content that's ambiguous like this, where comments on a piece might be in a different language than the piece itself, etc. And so rather than spending the CPU power on classifying each bit of content, which is much more expensive, we realized we had a better data set. So we grabbed the language request headers from the browsers of every browser requesting any URL. This is part of the HTTP standard. So Bitly uses 301 redirects. There's no fancy JavaScript there. It's just whatever we get in the headers. And that data looks like this. It's pretty, we're all nerds here. You can understand what this means, right? Not hard to parse. So for any given URL, we just build that distribution and look at the entropy. And then we pick the one with the highest votes most of the time. We do have to bias English down because pretty much everyone requests their native language and then English, but once you account for that, we have really accurate language labels on a URL basis based on that click distribution. And there's the code, so you can see it's Python, and it's actually not very complicated. And so now we see things like this, which happen a lot, and we know that this is indeed Japanese. It's not really English. And that means that we will only expose this to Japanese speakers. All right, so my last thing I wanted to talk about was, sometimes counting isn't sufficient. It really is most of the time, but sometimes you do have to do interesting stuff at scale. And even there you can often cheat. So I just wanted to show you something we're working on and maybe get some feedback. So we have a system we built called DragonEye. It is the idea being that we have this stream of data coming through Bitly, and it looks at that stream and in an online way tells us what is interesting right now. So for every phrase extracted from every URL, we're building a continuous time series model of attention where a click indicates attention to that phrase. And we do it continuously because it turns out, as my colleague Mike Dewar will tell you, binning sucks for time series data. And it's kind of a fun model. I'm running out of time, so I won't go through the math here. But we took that, we simplified it. The simplification is really important. It's continuous, it's linear, so we took, so it's a sum, basically, and it's really, really fast. And then we chose a distribution that was smooth and a biased function, such that something that begins to show up will not be considered to be bursting in our data yet. And I know math is awesome, but I actually just want to show it to you. And let's hope this works. All right. So these phrases on the top are these things that are currently happening on the internet. And we can bring up the URLs. I should warn you that this is not being censored in any way, and it is the internet, so I can't tell you that something inappropriate won't show up here. In fact, side boob was the top key phrase when I was looking at it on my laptop just before, and I'm glad it's gone. The colors you see pulsing are actually human beings clicking on these links. And so the current system latency is 8 seconds from click to display here. And we're working, that actually should be about half that, but they're doing some fun stuff with the system today. I don't know who Kelly Preston is, but we can go see. All right. I have the best job ever. This also lets us do some fun things like say, okay, what's going on? There we go. So what are the links getting traffic on the Tumblr platform to Etsy.com, which are always hilarious. Or we can do things, by language. So I don't speak French, but hopefully someone here does. Oh, that's a bug. And the last one is we can do it by location. So I visited my cousin who's studying in Oxford yesterday, and we can see this is the subset of the data being clicked statistically disproportionately from Oxford, ranked by current popularity. Okay, I'm going to stop playing with this now because it's not getting better than that. And we do also, since I mentioned there's continuous time series models, I brought up the graph for Bieber, who is less popular in the UK, apparently. So he engaged in a public display of affection with his girlfriend, which caused this spike just recently. And if I highlight this, you can see that story is causing that particular spike in the graph. And this is our normal Bieber noise. It's usually pretty small. All right. Okay, so let's think again. There are huge opportunities for those of us who like to play with data and like to build systems and like to build products for real people. But I do think the phrase data scientist is at this liminal point where it will either become a thing that persists or it will become a thing that we will laugh at 2 years ago, 2 years from now. And I'm not sure which of those is true, and I'd like it to be the former. And so I'd like everyone to sort of work on making that happen. I'm not sure how, so I have a cartoon. That's all. I'm over time. Thank you. Wow.